Alright, today guys we're going to talk about section 9.5 and 9.6, which is complex numbers and polar form of complex numbers. So let's just start with a review of complex numbers. So remember, a complex number can be written in the form of a plus bi, where the a is going to represent the real part, and then the bi is going to be your imaginary part. Remember that the square root of -1 is going to equal I. Therefore, -1 equals I squared. That is something you will have to remember down the road. Alright, so if a complex number can be written in the form of a plus bi, we're going to have basic operations between two complex numbers. So the first type of operation that you might see is that you might have basic addition and subtraction. So what are we going to do when we add or subtract complex numbers? All you're going to do is distribute and combine like terms. So if I take this example right here, all I'm simply going to do is distribute that 3. So I'm going to get 6 plus 3i. Distribute the -2. I'm going to get -14 plus 6i. Now I'm just going to combine like terms. So I have a 6 and a 14 and a -14. That's going to give me a -8. Then I have a 3i and a 6i. That's going to give me plus 9i. So my final answer will simply be -8 plus 9i. Now when I multiply two complex numbers, see how they look like binomials. Well, how do we multiply two binomials? All we are going to use is FOIL. So to multiply two binomials together, to multiply two complex numbers together, all we're going to use is FOIL. So if I FOIL, I multiply my first two terms together, I get 6. Multiply my outside, I get plus 15i. Multiply my inside, I get -2i. Multiply my last terms, I get -5i squared. Now remember from the top, what did I say I squared equals? I squared equals -1. So if I replace this I squared with the -1, I'm going to get -5 times -1, which actually turns to a +5. Now if I go ahead and combine my i's, I'm going to get a 13i, and then I still have that 6 out in front. So if I go ahead and combine like terms, I'm going to get 6 plus 5 gives me 11. So my final answer will be 11 plus 3i. Now the last type of operation that we would have between complex numbers is division. Remember, I is a square root, so we cannot leave a square root in the denominator. So to get rid of that I in the denominator, you're simply going to multiply the top and bottom by the conjugate. And remember, the conjugate is simply the opposite sign of your denominator. So if I take a look at my denominator right here, I have a 3 plus 2i. So all I'm going to do is multiply by the conjugate, so I get 3 minus 2i. So notice we're multiplying two complex numbers again, so we're just simply going to have to FOIL. So if I go ahead and FOIL, I'm going to get 12 minus 8i minus 3i plus 2i squared. In the denominator, notice because they're conjugates, my middle term is going to cancel. So I'm going to take 3 times 3 is 9. Then I don't need to worry about multiplying the inside and outside terms. I'm just going to multiply my last to get a minus 4i squared. So this plus 2i squared is simply going to turn into a -2. The minus 4i squared will turn into a plus 4. So if I go ahead and combine like terms, I have 12 minus 2 is 10. I'm going to have negative 11i on top. And then on the denominator, I'm going to have 9 plus 4, which is 13. Now we want two distinct parts for my answer, so I have to break that up as 10 over 13 minus 11i over 13. And that would be your final answer. So our basic operations, really not a whole lot that's new in order to add, subtract, multiply, or divide complex numbers. Now the last thing that should be a review for y'all is simply simplifying I raised to the nth power. So n can be just a real number, and so there's two cases that we're going to have. Either n is going to be even or n is going to be odd. So we're going to come up with basically two different rules to how we're going to simplify this based on whether n is even or odd. So let's first take a look at if n is even. So if n is even, so if I have I to the n and n is even, we're going to rewrite it in terms of I squared. So I'm going to say I squared, and then all we're going to do is take that n and divide it by 2. So I would say I squared raised to the n over 2. So let's take a look at a couple of examples using that rule that we just came up with. So if I take a look at number 1, I have I to the 20th power. So 20 is even, so I'm going to write it in terms of I squared. All I'm going to do is say, okay, what's half of 20? 10. Now the reason we're writing this in terms of I squared is because what does I squared equal? I squared equals negative 1. So now I can replace that I squared with the negative 1. So we're going to say, what is negative 1 raised to the 10th power? Well, you can use your calculator if you want, or we know 1 raised to anything is going to be 1, and a negative number raised to an even exponent is going to become positive. So negative 1 raised to the 10th will simply be positive 1. So I to the 20th equals positive 1. Let's take a look at another example. So if I take a look, number 2, I have I to the 50th. So 50 is even, so I'm going to write it in terms of I squared. So 50, half of 50 is going to be 25. So I'm going to say negative 1 raised to the 25th. Alright, this time negative raised to an odd exponent is going to stay negative. So my final answer will simply be negative 1. Now you'll notice here in my last two examples, 73 and 13 is odd. So we need to go back up and come up with a formula or a rule that we're going to use when n is odd. So let's say n is odd. So if I have I to the n, and we're going to say I to the n is odd. Well, how can we make n even? Well, what we can do is I can pull out an I. If I pull out an I, I'm going to be left with I raised to the n minus 1. Alright, the reason we're going to do that is because we want an even exponent so we can use our previous rule that we just made. So now let's kind of go down and apply that rule. So we said I to the 73rd is odd, so all I'm going to do is I'm going to take an I out. If I take an I out, I'm left with 72. Now notice I can rewrite I to the 72 just like I did number 1 and number 2. So I'm going to bring down that I. I'm going to take I to the 72 and say I squared. Half of 72 is going to be, what, 36. So now we can say, okay, I times, well, I know I squared is negative 1 raised to the 36th power. So what's a negative number raised to the 36th power? It's going to be positive 1. So we're going to have I times 1, which is I. Alright, let's try one more. So again, I have I to the 13th. So I want to make it even. So to make it even, I'm going to take an I out, and I'm going to get I times I to the 12th. Now I can say I to the 12th is going to be I squared raised to the 6th power. So I'm going to get I times I squared is negative 1 to the 6th. Well, what's negative 1 to the 6th going to be? Well, that's going to be a positive 1. Then when I multiply, I get my final answer as I again. So this right here was simply a review of complex numbers that you should have covered in Algebra 2. And so this is just dealing with complex numbers in a rectangular coordinate plane or algebraically. So the next thing we're going to go ahead and cover are complex numbers in the polar form. But for right now, I'm going to go ahead and stop the video, and I'll continue on with the second video.